Hi, I'm Bill Malik, Chief System Architect with EnterpriseWeb. I'm going to be giving a demonstration of a single pane deployment and management of a disaggregated cloud-native 5G core. The demonstration is delivered using NetOps AI, Tech Mahindra's integrated solution based on best of breed, where EnterpriseWeb plays the intelligent orchestrator. So the use case is pictured here. It's a cloud-native 5G core over 3 separate hosts. We can see that it's going to be across Amazon EKS, Red Hat's OpenShift that's hosted, ROSA, and then an OpenShift on-premise cluster with the control plane, UPF, and PCRF distributed across the 3. NetOps AI and EnterpriseWeb are deployed in Amazon EKS to control the overall solution. Here we can look at it in a little bit more granular way, but you can see all of the same components and basically how they're all configured across the solution. Now we're going to actually dive into, for the demo, how we delivered this. We'll do onboarding, composition, and then deployment of the service. And overall, the demo will show how this was able to be deployed using a single pane of glass quickly and easily. First, we get to onboarding solution elements. So we're going to use the EnterpriseWeb to do that, but first we're looking at the fact that we're deployed in EKS. There's the EnterpriseWeb runtime that's going to be delivering this entire demo. We start by logging into one of the modules it exposes, an application manager that's used by a developer to onboard the different elements that are going to be used. In this case, it was that PCRF and the UPF, etc. What we see here is a catalog of objects that can all be composed into those solutions. We can see the Casa components, for instance. We could drill into any one of them. Here we're drilling into the UPF. Each one is wrapped in a case, so they have consistent governance, security, and management, and all those kinds of things can be done. And this is over any object, the services themselves as well, not just the elements in this case. But what's most important is when we actually drill into an object, the system is collecting everything that's going to be needed not only to be able to deploy this, and when I say collecting, it's either prompting this from a user, or it's literally, in this kind of a case, it's actually generating it from an onboarded artifact, which you'll see in a minute. But the system will go out of its way to autofill as many properties as it can and make this really easy for you to be able to compose these solutions together. So here we can actually see us taking a sort of typical component. This was actually the ENEA deployment. They provided us with a bunch of YAMLs and the kind of Helm charts that you might need to actually do the deployment. And what we did in EnterpriseWeb was we actually went and we could either onboard these through an API. You can see here a declarative API that any user can use to onboard these elements, very easily, quickly, without writing any actual code. Or what's most effective and nice here is a lot of artifacts can actually be done in a completely UI-driven way. So here you're seeing me actually onboard the ENEA PCRF. I'm taking that package that you saw a minute ago, which included those YAMLs. You can see it here as a zip file. I'm uploading it into the system, and the system's going to extract all the detail about how to actually work with that PCRF. So you can see here, in less than a second, we mapped the PCRF. So it became a code package. This included its application behavior, which is really important. It identified, based on elements in the packages, that it was a PCRF. So the system understands now how not just to deploy and stand up the service, but also how it can work with it at a higher level, how it can actually chain it together through its standard-based interfaces and so on. You can see some of the properties here that were extracted, things like Docker repos and so on. And what we get as well is a set of interfaces that were actually generated for working with it. So if we wanted to, we could just start using EnterpriseWeb like what they used to have in Etsy, a VNFM, to actually deploy it through Etsy standard interfaces. This is all generated by EnterpriseWeb. There's no additional code needed or anything like that, even to the point of instantiating it. And so we could even just stand this up, individually. Now, behind those APIs are actually a set of mapped lifecycle operations that you saw, and of course all the detail that's needed for what the system should stand up in terms of NFCs and so on. And what's making all of this possible, though, is the graph that the EnterpriseWeb system is actually building during onboarding. It identifies at a high level all the kinds of components that are going to be needed either to deploy this on its own or compose it with other services. So now we're going to actually look at what the results of that composition are. So if we log in as a different user here, so a service manager, someone actually concerned with using those elements that were onboarded, their job is actually pretty simple. You can see another catalog here, just elements that are slightly different, but you see all the Casa elements you might want to compose in here, the ENEA, PCRF, for instance, etc. But also all the cloud hosts where we might want to deploy. And also we can even see services that have already been composed. Here we're actually looking at the Casa control plane. So in this case, we're actually going to build our service we want to deploy out of a bunch of smaller components. So this, you can see the AMF, SMF, etc. have already been composed. There's already a template, if you want, in EnterpriseWeb we can reuse for this composition. Now what we're going to do is proceed to actually build the service that we want to deploy. We're going to make use of that service template that already exists, some of the standalone elements. You're going to see how easy this actually is. We just walk through what's basically a simple interface here, and we're going to really just go in and say, okay, well, at the beginning this thing starts out empty. It's a template for a 5G core, but what we're going to do is go into our catalog, and we're going to actually pick out, okay, there's a service. There's the control plane service. So we're going to use that as one component. It's already been configured, all of its descriptions. We're just going to assign it to the host we want, so ROSA, and then we're going to arrange it into a service graph. We're going to just repeat this for each of the elements, or if you want, composite service components that we want to put together. So here we've got our UPF. We'll put that in the OpenShift on-prem. And all the details for that on-prem, the connections and everything else, are already detailed in the model that it has. So we don't have to go and do anything additional. We could set intents here. We can actually say, okay, for the service chain that we want to set up between that control plane and UPF, we could set some additional policies if we want. We can go in and configure the individual elements, so things for the UPF like the version and so on, affinities and what have you. And we just repeat this for each one of the components that we want. It's a pretty simple and quick process. And it really saves the service designer from having to understand a lot of the lower level detail. For the most part, what they can do is really just at a high level declare what they want, how it's connected, and where they want it to deploy. And the system will go ahead and actually do things. You can see these are all the instantiation parameters it defined based on what our selections were. So, and it even put together an actual deployment plan based on the components. You can see here it's relatively simple, instantiating control plan, what have you, but that's driven from all of the understanding the system has of the elements that were to be composed. Now we'll deploy our service and see how we can actually make use of this. So again, we're in the catalog. We can see our 5G core, and the system actually exposes that set of interfaces you saw before, APIs and so on, that we could use to do the deployment. You can see here our composition model we had from earlier. We know which clouds we're going to deploy, and we'll just pop into each one of them before we do the deployment. Just take a look, okay? So we can see that right now our Casa space is actually empty. It's just got the jump box or jump host that we're going to use to do the deployment. So there's nothing in OpenShift right now. ROSA, there's in the OpenShift on-prem, it's also going to be empty. You can see no workloads yet. And then similarly, we'll just go in and take a look at the, the EKS environment as well, just basically to show where our target's going to end up. So you can see just the EnterpriseWeb runtime that's there right now. And then if we go to the PCRFs, again, it's empty. So now we'll go back into EnterpriseWeb, and we'll actually just use the UI for this deployment. We could actually use the APIs that we talked about earlier, but it's just as easy. We see all the parameters that we need, makes it very easy if we're swapping licenses or what have you. And this, of course, extends to whatever level you want. So our demo example. So then what we see here inside the system is as we walk across each of those clouds, we'll actually see it deploying. In the system, there's always going to be this sort of lifecycle management that's being tracked. We can see a trace that goes down into the actual particulars of each one of those service components that's being deployed, including the kind of local IDs that would be actually used to track across, what cluster, what pod, what have you. All of that detail is going to be tracked in EnterpriseWeb. You can see the PCRF there being deployed in EKS. If we jump into another one of the elements here, At a lower level, we can see the operations that were actually used to work with it. If you want to, you can drill down to a low level space, but you can see that it's using a jump host and how exactly it's translating a generic command into a specific one. But if you note, we didn't write any of this, what would effectively be, sort of remote CLI commands or working with Kube Connect, what have you. None of that was actually written by hand whatsoever. It was all just generated by the system, automatically translated into the commands that were needed. Here we can see the same thing was happening for our UPF. And at whatever level of granularity you want, you're going to be able to trace this. It's all a transaction, as we talked about at the outset. So this entire thing, if anything were to fail, it would all roll back across the 3 clusters. You don't have to clean up any individually. And here we see the Casa components that were deployed. And then I think, you can see, exactly. They're even deploying as we speak here. And really, it's a matter of, under a second, all of the commands are issued. And then really the only wait that you have is for the actual elements themselves to complete their initialization life cycles. You can see all the pods, etc. And this is, of course, across multi-vendor. So this is the Casa set of components, and then you can see even a headless on-prem deployment has all of the specific components set up. So within a minute and a half, we have a full running service that's now ready to be used.